Return your student Professor Dr. Dolphy Gilpin, and we are here focusing on Promethium, a lanthanide series element, atomic number 61, atomic mass of 145, and F block element, period 6. And let's continue. So let's look into now some reaction of Promethium. Promethium atomic number 61, 145 atomic mass. And we go straight into the reaction here. Reaction of Promethium with halogens, quite reactive with the halogens family here, or the halogen group. And so you have Promethium plus fluorine will give you Promethium 3 fluoride. Likewise, the rest of the halogen family, Promethium PM plus Cl2 will give you Promethium 3 chloride, PmCl3. And Promethium plus bromine, PM plus Br2 will give you Promethium 3 bromide. And also iodide, Promethium plus I2 give you Promethium 3 iodide. So it reacts with the halogen family quite reactively. Reaction with oxygen, Promethium plus oxygen will give you Promethium 3 oxide as well, PM2O3. Which is that in the formula you have PM2O3, the 3 comes over crisscross to the P, the 2 comes from the oxygen over with the oxidation state of 2 to the PM, and the 3 from the PM goes over to the oxygen 3, so you have PM2O3. So Promethium react readily with air to form Promethium 3 oxide, PM2O3, and Promethium is radioactive, as you know. The lanthanide series most of them are radioactive, right? And its salts are quite toxic. And if it's toxic, then if inhaled, it can cause lungs damage, and come in contact with the skin, you could get skin burns as well. Now, bombarding this enriched uranium with thermal neutrons produce Promethium 147 atomic weight. So here's one of the isotope, which is derived by bombarding thermal neutrons from enriched uranium to give you the Promethium 147 atomic mass. So that's one of the isotopes, and you know that isotopes have constant atomic number, so that the atomic number will remain unchanged at 6 to 1. And likewise, you know, when neodymium 146 is bombarded with neutrons, it produces neodymium 147. So neodymium likewise, which is nearby in the lanthanide series there with Promethium, we bombard that with neutrons, you get an isotope, neodymium 147. And you know neodymium is very useful for magnets. They form very strong magnets, very strong magnets. Now the salt of Promethium glows with a pale blue or green color, while the metal itself is silver white. You can also get Promethium. It's been detected in the radioactive decay of uranium. So you'll find small traces of promethium in the radioactive decay of uranium. And you know the radioactive decay of uranium will also give you some plutonium as well. Plutonium probably 239 there, or 238. So that's our introduction to promethium, PM symbol, atomic number 61. Most stable would be available promethium would be promethium with atomic weight of 145, and we just look at one of the isotope with promethium 147, which is derived by bombarding thermal neutrons from uranium to get you this promethium 147 atomic weight. F block period 6. So there we have it, promethium, and use it again, and we noticed by bombarding uranium by thermal neutrons, we're focusing on this, but this comes up in one of the isotope, then we get bombarding this uranium with thermal neutrons, then we get promethium 147. All right, so let's take a break and let's just focus a little on another element of the periodic table.